Okay, good afternoon. It looks good, right? I don't have to turn off the lights today. It's kind of dark outside today. Um, so today we're gonna continue our modeling, uh, lecturing in terms of how to build models using a computer for manufacturing systems. We are still working with Arena. We're gonna spend time today looking at some additional blocks and elements. Specifically those that are associated with assigning attributes to some of these entities or parts that are going to be moving through the simulation. And then the second part of the lecture will look into computing specific statistics and how do you run more than one experiment and how you compute the performance statistics for multiple experiments. Let's say when I say experiments, these are replications. So typically, when you build a simulation model, once you verify and validate that the model is performing as you expect, that is representing the system that you are trying to model, then the next part will be to use the model for experimentation. And during that experimentation process, the idea is that you use your model and you test your model under different scenarios. In this case, that could mean, for example, different arrival patterns. So your parts are arriving every 2 minutes. You want to also test not only every 2 minutes because that's constant, but let's say you're using a probability distribution to represent that arrival process, like the exponential distribution. These probability distributions are based on random numbers. Like if you provide a specific random number, the set of inputs that the model will receive will be based on that random number generator and the seed that you provide to that random number. So when we do multiple experiments, what we are changing is the seed that we use to generate those random numbers. So every time we change that seed, we get a different set of inputs for our simulation that's still based on the same probability distribution, but the set of inputs are going to be different. And we do that because we want to make sure that the model is robust. So we want to test the model within this different set of inputs and see how it performs. In terms of looking at the performance, then we want to generate a summary report that takes into account all these experiments. This summary report, I'm going to show you how it looks in a few minutes, but it will have not only information about the average statistics, but also provide some confidence intervals in terms of where that, what is the variability associated with that performance metric that you're using. So that's mostly what we are going to be focusing today. Defining some of these new attributes and also how do you compute these statistics. So some of the slides for today are going to be similar to what we saw last time. So I'm not going to go over those one more time. But remember, this terminology is important. Make sure that you understand what is an attribute and the difference between an attribute and a variable. Because today we're going to be looking at attributes, then next time we're going to talk about variables. So just remember that an attribute is a property of an entity that's not changing, right? So for example, if you assign this is job type 1, the entity will be a job type 1 throughout the simulation until it is discarded at the end. If you assign an arrival time for this part, the arrival time is not changing, right? That time is assigned to the entity and it's not going to change until the end of the simulation. So those are the type of properties that we are going to be working with today. As always, remember to save your work, right? So make sure that you are saving every time you make some significant progress on your model, that you keep saving. And then this is how you set up your experiments, right? So every time you save, also you're going to be setting up your your model in terms of project parameters. So you put your name and the type of report that you want to generate is the one that we're going to be using is the Siman summary report, which is the Notepad version of the report. And then we're going to change the replication parameters based on the model that we are building. Today, we're going to be looking at multiple replications. Okay, so last time we talked about resources. So again, this is where you go and define those servers that are going to be part of your model. These are the entities that are going to be taking care of your jobs, right? Or the entities that are flowing through the system. So in the elements, we're defining the names and the capacity. Again, the capacity in terms of having identical servers. So if you have multiple servers that are identical for same station, you go here and you define a capacity for that station. And then to define in the actual model, how you represent a server or a resource, you need a cease, delay, and release block. And we talk about how do you use them in a sequential order. And most of the time you have a queue in front of it. So in case that the servers or the stations are occupied, you hold those entities until one of those servers become available. So what are the new modules for today? As I mentioned, we are gonna start working with the attributes. And then for assigning those attributes, we need to have an attributes element. So here's where we're gonna define the name of that attribute. So it's like when you're coding, right? You have to define if you're gonna be using an integer variable, a string variable. You're doing the same thing here. You're defining the attribute first, and then you can use it, right? If you don't define it, the system is not gonna recognize it and it's gonna give you an error. So yes, sir.
Would the attributes block be an individual block that you assign a particular entity, or is the attribute block gonna be like the resources block to define the whole?
That's a good question. If I'm following, you only need one attribute element block to define all the attributes that you need for your model. Good question. Yeah, so you don't need to have separate attributes element blocks. You only need one, and here you can define all of them according to your model. Same thing with the assign block. This is now going into the model part of it. So once the entity flow through this assign block, that's where you assign that property, right? And this could be placed in different locations within your model, depending on when you need to define those attributes. Most of the time, we assign them right after creation. Now you create the entities and you want to assign, for example, the arrival time, or if there's a specific job type, you want to assign that right away. But there will be some cases in which you might need to assign or reassign some of these attributes. And those blocks can be located in different places within the model. So the assign block allows the assignment of a value to user-defined entity attribute. One of those is, as I mentioned already, the arrival time. And to get the time from the simulation, there's a variable that is defined by the software that is called tnow, and that's the one that I'm highlighting here. This tnow is a miscellaneous system variable that provides you with the current clock time, and is used to calculate the cycle time of the entity. So once you assign let's say you want to assign the arrival time for your entity, you're going to define in the attributes element that name, arrival time. But when you get to the assign block, it's gonna ask you, okay, you want to assign something, what do you want to assign? You're gonna look for the arrival time, and then it's gonna ask you for the value. The value will be this variable right here, tnow. So that's the value that you want to assign, whatever time it is at the time the entity crosses this block. That makes sense? Okay. So assigning the attributes, here's the window. When you double click this block, this is what you're gonna see. So typically we'll be looking at working on this area. We're going to talk about this top part later on. So here is where you'll see that there's a variables name here. Is okay, don't worry about that. Because here you're gonna add, and when you add, you'll see that there's a distinction between attributes and variables. So you're gonna choose the one that you're gonna use. And in here, I'm looking at the start time T now, basically that little block that is gonna show up once you click add is gonna ask you for the name and the value. And as you can see here, you can define as many attributes or variables within the same assign block. You can have the only one assign block and assign all of them, or you can have them separate. It's gonna do the same thing, right? So if you want to save space, then my recommendation is to just use one of them and then list them within the same assign block. But if you wanna don't get confused and maybe separate the attributes when you're coding, you can also put assign block after assign block after assign block, and each one of them will have a separate attribute. Another important block that is not, this one does not require a element, right? This is called a branch. And this is basically like an if statement that is used to check for a condition and split the entities based on that condition. So again, this is called a branch. And looks like that. You're gonna have an input and then multiple outputs depending on the number of conditions that you will need for your decisions. If it is a yes, no, then you're gonna have one input and two outputs, one for yes, one for no. But if there's multiple, let's say for example, here you have multiple part types and each one of them is taking a different route. You can have as many part types as you need. The number of branches will be the same number of part types, right? So you are gonna check if it is part type 1, you go through this branch. If it is not, then until you find the attribute that matches your condition. So that's what we have here. You define the branch types. You can use if statements to separate them. And then one thing that is very important is to make sure that you put in a 1. If it is not by default, you need to check. Sometimes, depending on the version, I'm seeing both. Sometimes it's there by default, sometimes it's not. You need to make sure that the maximum number of branches that each entity can take is 1. Because if not, then the software will have some duplications. Not a lot, but it can affect your results at the end. So it's important for us to make sure that we force each entity to take only one branch. So for example, you can have an else statement, like if else. If that else is not specific, and that entity might get duplicated and go through that else as well. So we'll see that in a minute. Yes, sir.
Sorry.
Yeah.
So it sounds like branch is kind of like the logical gate.
Yeah, you can see it. I mean, programming will be like an if statement, right? Yeah.
Can you have more than one if statement inside of this block, or is it used usually for just one question?
You can arrange this branch as you need. Like you can have multiple branch working together. Let's say you're separating them by part type and then maybe by arrival time. So let's say all of them come. Let's say you want to split the part type 1 into another group. So you can connect that branch to another branch and then continue doing the logic as needed. Yeah, so yes, that's it. The software allows you to do that. Yeah. So let's talk about statistics. Okay, so those blocks and elements we're focusing on this logic. Now we want to connect all this logic to the performance of the model and the system. So we have multiple statistics that are relevant for most simulation models. Those are the ones that we're gonna discuss today, and then we're gonna keep adding as we move forward during the semester. The first one is the one that you use in your first assignment, which is the counters and count block. So this is very simple. Basically, you're trying to count how many entities are completed, or in your assignment, how many of them were discarded per machine. So the counters element will allow you to define, as we did for the assign of the attributes, we name the counters, and then we use the count block to assign that or to locate that counter block where you need it. So counters is the first one. You counters, you define the name, you put the count towards the end of the model to count, or if you're counting the discard of entities, you place it at the time of counting those entities. So for example, number of units completed, that will be typically what we're gonna use these counter blocks and elements. So another group of statistics are called the tally statistics and the time average statistics. These are time persistent statistics. So let's talk first about the tally. Tally is data which there's a natural first, second, third observation. And then what we try to do, we tally them. You're basically putting them into, let's say, a bucket. Right? So if you, for example, you're looking at the cycle time, every time an entity is completed, you put that cycle time into this bucket. And you start, let's say, number 1 is 10 minutes, number 2, 12 minutes, number 3, 11 minutes. So every time an entity crosses this tally block, you look for that value and you put it into this bucket. At the end, you're going to end up with a list of numbers that are representing all the values that you have collected from the simulation. So what do you do with the tally? You can do things like computing the average, the standard deviation, confidence interval. So the idea is you're collecting information from the entities in terms of their performance, how long they stay inside the system, and so on. You're grouping them, and then at the end of the simulation, you call, let's say, that array of values, and then you use that array to compute some of these statistics. So that's what the tally is doing. Values are tally when they're observed. For example, the cycle time. And then we have these TAVG. This is defined by ARENA, and it is used to obtain the average across replications of tally statistics. So let's talk about that a little bit. So at the beginning, I mentioned that you have your model, right? Once the model is verified and validated, meaning that when you say verified, basically what I'm saying is through verification, you're making sure that the model is doing what it's supposed to do, right? Like you want the model to go 1, 2, 3, and you verify the model goes 1, 2, 3. When you validate, basically you're checking whether or not the system that you're modeling is accurate, meaning that if it takes 20 minutes to complete every part, when you run your model, the model is telling you, yes, it takes 20 minutes. my model is representing what's happening or close to what's happening in reality. That's validation. Verification again is this is the set of sequence of logical steps that I intended to program. I use that, let's say a flow chart or whatever you use to plan your simulation. And then you check that your model is representing that set of logical steps. Then you check if it is validated, meaning that it is representing the actual system. Once that's completed, what follows is the experimentation. So we can call these experiments or replications. So every experiment that you run is going to be based on, we'll have some uncertainty. So let's say uncertainty 1, and this is typically based on the seed that you're using to run your probability models. So this is experiment 1, experiment 2, experiment 3, 4. And every time you run this, there's going to be some performance measures. Let's say cycle time. Or another performance measure. This with performance measure number 2, parts completed. So when you run your model, let's say for experiment 1, you get cycle time 11, parts completed 154. And then you run your second experiment, and this is automatic with Arena. You tell I want to run 10 replications, and it will run them automatically. So let's say this one is 20, and then this is 101, this one is 15, and this is 122, and this one is 14, and this is 130. So each replication is giving you a different value for parts completed and cycle time. What does this mean? Well, it means that since you're using different random seed for your probability distribution, the uncertainty is different. So you're running your model now with different inputs. So you should expect to see different results. They are not as different. I mean, they shouldn't be completely different, right? They should be somehow close to each other, but they're going to be different. So what this TAVG, let's say your cycle time is your tally. And this could be also another tally, parts completed. But in our case, this will be a counter. Let's define it as counter. Then we can use a tally. Well, this is a tally already. We can use a TAVG. For this tally, let's say cycle time, to obtain the average across replications. That'll be 31, 46, and 460. 60 over 4, that's 12, right? So your average across replications for cycle time will be 12. And also is going to give you, it's 15, sorry. Math is off. Thank you. And then it's also going to give you a plus minus for the confidence interval. So it's not just giving you the average, but also the uncertainty between that number and the variability observed. So what would you expect? And this is maybe a question that is not necessarily about this class, it's more in terms of your knowledge in statistics. If you want that confidence, let's say this confidence interval is 15 plus minus 10, right? So it tells you this average could be, or the real value, the actual average, the actual average for this experiment is between these bounds, right? What would you do if you want to reduce the size of those bounds?
Reduce the percentage of the confidence interval.
Meaning that you want to make this smaller. Yes. So there's, if you remember the formula, there's something that you can do to your experimentation to make this confidence interval smaller. Well, standard deviation is more in terms of the variability observed. But there's something specific, and it's related to the number of experiments. Like you should observe that as you increase the number of experiments, the size of the confidence intervals should be decreasing, right? So typically that's once we get into the actual insights of what you're observing and making recommendations, that's one of the things that you will be looking at. How many replications should I run in order to get an insight that is supported by these numbers? Okay, so that's pretty much what we are going to be trying to do today. We're going to teach you how to run this report that is going to take into account these multiple experiments. And to, yes, sir.
So for the TAEP, is there an ability to reach into the program and grab some of the other data that it uses to calculate the confidence interval?
So can you get access to that bucket of value? Is that what you?
Yeah, like instead of drawing the confidence interval,
Yes.
I wanted to model a histogram with the information just to understand what the distribution would look like.
I think there's, I mean, I might be wrong in this. I know you can draw histograms automatically with the animation portion of the software. What I'm not 100% sure is whether or not you can go into the numbers and get the data from the software. But even if you cannot do that, you can, if you're interested in doing that, you can find a way to manually get the information, right? Like get the values and put it in other, or print them so you can, use that. Yes. Good questions. Okay, so that's in terms of tallies. Trying to see if this goes away. Another thing that we'll be using today is this element called sets. And this is to help us split some of the information that we're collecting from the tallies. So again, this can be done two different ways. You can use a branch to separate the part types. Let's say you have 3 different part types. and you can use a branch to separate the entities based on part types. And then you can tally those by group separately. So this branch is part type 1, I'm tally only part type 1. This branch is part type 2, I'm tally on only part type 2. Or you can use a set element to separate, do the same thing without having to incur into the logic of adding that additional branch and have those additional tally blocks. So that's what we are trying to illustrate here. You can define a set name, cycle time by part or CT by part, and then you're gonna tell what are the members, right? So CT1, CT2, CT3, and then those members are basically names coming from your tallies. So in this case, what you have is a set that has 3 members that are tallies already defined in the tallies block. So what it's going to do, it is going to be based on the part type. The order will be following that part type order. So you have here you have 3 rows. Row 1 belongs to 1, row 2 belongs to 2, row 3 belongs to 3. So what this is going to do is going to look at the value for that attribute, and it's going to say, okay, so if your job type is 1, I'm going to assign your observation to the first tally. Your job type is 2, I'm going to assign it to the second tally. So I'm going to show you how that works, but that's the idea. You have your tallies defined as you would do. Like if you want to know cycle time 1, 2, and 3, again, you can do that by separating each one of these part types by a branch block, and then just collect the ones that are linked to your part type, or you can use a set that will save you a lot of blocks. The only thing that you're gonna have to do is to define the set using an element set, and then when you get to the tally, you're gonna call that set, and you're gonna tell, look at the attribute, and based on the attribute, place the entity value on the right bucket, which is gonna be one of these 3. Okay, so we'll do that manually in a minute, but that's the idea. And then finally, we have what we call time persistence statistics. So these are not observations that you're collecting at the end of your simulation, like observations from the entities. These are statistics that are depending on time. Like for example, the resource utilization and the working process. Okay, so what do I mean by that? When you look at the resource utilization, for example, you can have, gonna try to use a graph to explain this. Let's say this is the percentage BC. And this is gonna be based on time. And this could be 100%, 50%, 25%, 75%. But this is a statistic that is changing, right? It's not a static number. This is something that you start at 0, and then let's say after half an hour, 1 hour, 1.5 hours, 2 hours, and so on. This can go up and down, right? Because it's going to depend on the entities that will be arriving to your station, right? So maybe at the first 30 minutes you were not, during those first 30 minutes you were not as busy, but then the next half an hour you got a bunch of parts, so you were working a lot during that time. So what I'm trying to illustrate here is that this is not an observed number at the end of the simulation, like a tally, like cycle time was this. This is something that is changing cross time. So what this what we call this time statistics, they are time persistent. So what they're gonna do, don't remember exactly 100% the math behind it, but the intuition behind it is like you're looking at this area under the curve to determine that time average that you are busy in this case during the simulation run, right? So that's what this is going to do. We're going to measure some of these statistics like utilization. Working process is another one. How many entities you have inside the facility at any time. That's something that is changing across time. So that's another value that we're going to track using time persistence statistic. And the way you collect the information for this stat or for a time persistence statistic, you say you use this element block called stats. And for utilization, we use a software-defined variable called NR. NR will, with the name of the resource, will tell you, will compute this time persistence statistic for you in terms of utilization. Yes. Yeah, that's there's not specific name associated with it. I think it's something associated with number resource something. But I don't remember exactly, but it's like TNOW, NR, and not some others that we are going to teach you here in class. And they're user defined by the software. Yes.
Is there a page, kind of like the expression builder, where we can take a look at all of the potential?
Yes, that's a good. Yeah, I have a sheet with all the names and the definitions that I'll typically post in the Canvas site, and I'll do that for you guys as well. Thank you. If any of you can just send me a reminder, I have it in the Canvas. I just need to upload it to the right then. Okay, so statistics for multiple replications. We're gonna call this outputs element to compute those. We're gonna use DAVG for time persistence statistics, DAVG for tallies, and NC for counters. Okay, so I know this is a lot for today. I need to present this to you. Well, as we move forward with the semester, you're gonna get a lot of practice on how to code this different statistics. So when we get into defining that summary report for all replications, these are the three things that we need to use, right? So these are the three things that we're gonna call to build that summary report. And the summary report will look like this, right? You see output summary for, in this case, 10 replications. It would show you the average for the performance metric. It's going to show you the half-width for the confidence interval, the minimum, the maximum, and the number of replications taken into account. Yes.
What is the half-width?
So the half-width is that lower or upper bound for your confidence interval. So what you're gonna do to get the upper bound is to add this number to the average.
3 sigma?
Yes, and then you're gonna subtract these halfway to get the lower bound. Yes. Okay, so let's work with this model. This is what we're gonna be building this afternoon. Looks very similar to what we did last time. The only difference is now we had two different part types, A and B. And we have interarrival times that are 4.4. We had two machines or two drills. Drill 1 only works with part type A. Drill 2 only works with part type 2 or B in this case. And then the processing time for each one of the drills is listed next to it. And then there's 10 replications or 10 experiments that we are gonna run. And for that, we're gonna compute these 5 statistics, the average cycle time for all parts. And this is the average across replications for all experiments. Average cycle time for part type A, average cycle time for part types B, average utilization of machine 1, and average number of parts completed. Okay, so I guess we're gonna spend most of the time here. This is gonna be, I think, simple because it's very similar to what we did last time, but building that report is gonna take us some time. So let's see. So I'm gonna open Arena. Okay, and then I'll save this just to make sure that I have a file associated with the model. And then remember that we are using the blocks and elements. So I'm gonna go here and look for those. Right click on the project bar, attach, and then click on blocks and template panel, attach elements. Okay, so I always like to separate the space into the experimental frame. And my model. Yeah, as you saw, I just copy and pasted it. And then double click and change the name. So I'm gonna start with the experimental frame. I know what are the things that I need. Those most of the time they're similar for every model. So I know I'm gonna need some cues. So I'm gonna start by adding, yeah, that's very small. So I need to increase the, or some this. So I got the cues. I need some resources. We're gonna use attributes this time because there's different part types. counters. So those are the counters are associated with the statistics. We are also going to use some tallies to collect the cycle times. And then we're going to try to use the sets or to separate the tallies. And then finally, since we're collecting the utilization, we also need to, as stated in the slides, we need to add a dstat. And then finally, to generate that summary report, we need the outputs. Okay, so from here, only the first three are linked to the actual model. The other five are for statistics and for creating the report. Okay.
Professor, can we explain when you are going to do this experimental frame, what's going on in your mind that makes you wanna?
Yes, that's a very good question. So in order to build the model, right? I know I'm always gonna need certain things to define certain things, right? And those are like when you're coding, you're defining, okay, these are the variables, these are the integer values, the string values that I'm gonna be needing. I don't expect you to do this right away. Sit down and identify all of them. Maybe as you start building, you will see, okay, I need an attribute. Let me add the attributes element and then add the attribute, the assign block. But I can tell you, every time you are building a model, there's going to be some resources associated with it. And if you have resources, you're going to have a queue. So those two should be there right away. If you have some type of definition for your entities, like assigning, most of the time you're going to try to collect the cycle time of the entities. So you know that you're going to need an attribute, assign an arrival time. So that's how I know I need the attributes element. And then the rest, as I said, the rest of them you might need or you might not need. These are depending on the statistics that you need to collect. Like for example, the sets is just a user preference. I will use the sets to collect some of the statistics, but I can build this model without the set. Counters, I know that I'll be counting the total number of parts completed, so I need to define a counter, at least one. Tallies, since I'm looking at collecting cycle times, I know I'm gonna need this bucket to collect the information, which is gonna be a tally. And then if I'm generating an output summary report, then the output elements will be needed. So that's, again, this is more based on experience. As you move forward, you will see how this works. The reason I'm asking you to go through this process is to be able to identify what things belongs to my experiment and what are the things that belong to the actual model. That's the idea of getting through this process. Why is that? Because you will need that for any software package that looks at discrete event simulation. There's going to be a section for you to set up the experiments. There's going to be a section for you to build the model. So learning to differentiate between the two is very important. Okay, so going into the experimental frame, I will try to define all the things or the names, all the names that will be needed for my model here now. So for example, I know if I look at this figure right here, there's gonna be a queue in front of, so you're splitting them, you get them arriving, but you're splitting them. So you need a queue for each one of these resources, right? So I'm gonna need one queue for drill 1 and one queue for drill 2. So yes, sir.
Because the two different drills taking two different types of products, is that gonna be one drill that you're defining twice, or is that gonna be two different drills that you're defining separately?
That's a good question. So the way to answer that question is by looking at their processing times.
I see.
If they're different, you gotta split them. Yes, that's correct. So gonna have two queues. Just gonna call it drill 1 queue. And then I'm gonna add another one. This is gonna be drill 2 queue. Then for my resources, there's drill 1 and drill 2. Capacity is 1 because I only have one drill per station. So capacity 1, and same thing here, drill 2. Okay. What about the attributes? Since I'm collecting the cycle time, I need to have an arrival time assigned to my entities. So that will be 1. Another attribute is going to be based on the type of part, right? So 60 and 40. In this case, you can work with this process of separating the parts in two different ways. Like, for example, you can have a branch block saying, without identifying the parts, only send 60% this way, 40% this way, and then assign the part type after process. That's one way to do it. But that's not my preference. I prefer to define the attributes from the beginning. So in this case, I will define the attribute from the beginning. I'm going to say 40% are going to be part type 1, 60% are going to be part type 2, and then I'm going to split them based on the part type, which is the attribute. But those two ways should not differ in terms of the results, because they're going to be doing the same thing. Yes, sir.
So you said that the numbers will for sure always be the same, no matter what.
They'll be very close. I don't necessarily say that they're going to be exact,
Okay.
but they're going to be very close. Again, because the way the random numbers will not the log, but the sequence in which they are generated is going to be different.
Okay.
But the numbers are going to be very, very close, even though you use different. So if you were to gather insights from the two models, they should tell you the same thing.
Would the correct thing to do, I'm sorry, in a real life situation, be looking at the actual manufacturing line and determining whether or not the part could potentially be the same part, or if they're inherently different? Does not matter.
That's a good question. So for example, we had similar problem with Toyota. Last year, we had a senior design group working with Toyota, and they had a discrete event simulation model. They were looking for tundras and sequoias, and they had a part that was different, and you needed to, both parts were into the same line. You just needed to identify when it went to a sequoia and when it went to a tundra. So in those cases, you need to determine whether or not there's a specific sequence that they are using to assign those parts into the line. Or if they're random, then you need to identify the type of part at the time of the action, right? So it will depend. I think in their case, there was a 2-to-1 ratio. Like they put 2 of 1 and then 1 after that, 2, 1, 2, 1. So it was simple for them to identify what part type was being next. What was next? But those, yes, in practice, that will depend on the actual process. Let's see. So attributes, there's gonna be two. I'm gonna start with the part type. So I'm just gonna define the name. So part type doesn't matter if it is 1 or 2, you're gonna be using the same name. You're just changing the value. So I'm gonna assign part type to you, you're gonna be 1. Part type, you're 2. Part type, you're 1, and so on. But you're using the same name. The only thing that is different is the value. And then the second attribute is arrival time. So I have two attributes, part type and arrival time. And then how many counters do we need? We're just counting number of parts completed. It doesn't matter if they're A or B. Okay, so we just need one counter. So I'm gonna call this parts completed. Construction going on. Close by. Maybe that building right there. Parts completed. Tallies. Okay, so those are associated with the cycle times. And I think we need cycle time for all parts, and then cycle time for A and cycle time for B. Okay, so we need 3 tallies. 1 for all, 1 for 1, 1 for 2. So I'm gonna use simple names here. CT for all. CT1 for A and CT2 for B. CT, CT1, CT2. The sets are, this is to differentiate between whether you go to CT1 or CT2. So we can give any name here. I can call this CT by part type. The important thing here is to make sure that you put the right member. So in this case, that will be CT1, CT2. So the set is going to split cycle time by part. So that's the name I use.
And the name of the members have to correlate to the names.
To the members that you're going to be using to, like if you're going to be splitting, you're going to be collecting information, then you got to put the members that are be collecting that information, right? So in this case, we have the tallies. Okay, CT by part type. What else? These stats, yeah. So what is asking here is the utilization of machine 1. So in our case, the name of machine 1 is drill 1. And as I mentioned here, to collect the utilization, we use this NR and the name of the resource, right? So that's what I'm going to do. I'm gonna go here at the assignment expression will be NR, and the name is the name of the resource, drill 1. I'm recording this lecture. I think this is one of those videos that you're gonna be watching, at least this part of the video, multiple times, because there's a lot of details here. So in the deed stats, something that we need to do, because it's required for us to generate the output report, is to put a name for the deed stat, right? So the name is right here after defining the expression. That name be drill utilization.
You want a number?
Yes, drill 1. Sorry. And you'll see why in a minute. Okay. And it's not gonna show up. That name is not gonna show up. It's just gonna show the Siman expression. But remember, we are collecting this data, and at the end, what we want to do is to generate an output report. So that output report is defined here by this element block, outputs element. And in here is where we're gonna put those TAVG, DAVG, and NC for the counters.
You don't need to do the inner or drill 2?
No, because we are only asking about machine 1.
Oh.
Yes. You can do it for practice purposes, but we are asking just for machine 1. So let's build the output report. Or maybe we can leave that to the end. Well, it's gonna give me an error. Let's do it right now. So Siman expression. So let's start with the tallies. So for the tallies, I need to do this for each tally. I'm gonna use the TAVG and the name of the tally. So for the first one is TAVG CT. If I don't give a name to this module right here, when you run and the report is generated, what is gonna show up is just the TAVG CT. If you're okay with that, that's okay with me. But I prefer to give a name. So this is gonna be the average cycle time. So in that way, when I look into the report, I know if you only have 3 statistics, doesn't matter. You can figure out what TAVG-CT means. But if you have 20, 25, trying to figure out each one of them will be a little bit difficult. So giving a name is important in those cases. So average cycle time. So I'm going to do the same thing for the other part types. TAVG CT1 should be 1. And the name, average cycle time, part type 1. And then for the next one, TAVG CT2, and the name is average cycle time, part type 2. Okay, so got 3 out of the 5. So I got 3, the cycle times. Now I want to build the utilization. Okay, so for the utilization, since this is a time average statistic, I need to use, instead of TAVG, a DAVG. Okay, so this will be DAVG. The thing here is, you remember that I stated you need to add a name. I forgot the name, so I'm gonna click OK here. I'm gonna go back here. This name that I use for the DAVG is what I need when I'm building this output right here for the dstat. And this is AVG drill 1 utilization. Okay, so TAVG is straightforward. You use the name of the tally. You put that into the TAVG. For these stats, you need to use the name. Okay, not the name of the dstat, because as you see here, when you enter the dstat, you don't have a name. You have an actual function. So that's why instead of using this, you need to use the name. So whatever this computes is what you need. Here you can use, because this is gonna call that bucket, and it's gonna use that bucket to compute this. But in here, this is a time persistent statistic, so something has to happen before you can use it into the output report. Okay, so let's click OK. And then we have the counter, finally. So for the counter thing I mentioned.
You're looking for the expression you use for the counters?
Yes, I don't.
It was down there. Go one more down. Another one. One more. It's more down. Right.
Oh, yes, right here. Thank you. So it's NC for counters. So we go here and see what's the name of the counter. Parse completed. And then we put here average number of parts. It's completed. And that's the last piece. So we got all 5. So as you can see here, I'm building that report. Right? This is what I built into that output report. So I click OK. Then I'm gonna save my model. Save. And now I have, this will be fast now because we have everything defined. So we can go into building our model. Let's go to the blocks. The first thing we're gonna do is to create some entities, right? So we use the create block. And we are using an exponential 4.4. So that's what we are using. So remember, we use the first 4 letters of the distribution. In this case, the exponential has only one parameter, so it is simple. But if you had trouble inputting the probability distributions, you can always go to this module and select the distribution. You input the mean, and then click OK. Next thing that I'm going to do is to assign those attributes. So I'm going to call this assign block. And there's two attributes that I want to use. First one is the part type. Right, so I need to remember the name. And then the value, if you remember that discrete distribution that we use on the previous model, I'm gonna do the same thing. I'm gonna say this percentage is gonna be part type 1. And so 60% are gonna be part type 1, 40% are gonna be part 2. So I'm gonna call, let's go to build expression, random distribution, discrete probability. So it's a community probability. So we start with 60, right? 60% part type 1, and then the rest part type 2. So it's going to be discrete 0.61, 1, 2. Part type. And then I'm going to add another one, which is the arrival time. So arrival time. And for this one, we use the software-defined variable tnow. So the arrival time we already defined, right? In those attributes, they're just, for some reason, the assign block doesn't give you a scroll down type of menu to select. So you need to type the name. So you got both part type, arrival time. Okay, next we're gonna use that branch block to separate the entities. See, this is automatic there by default, only one branch. And then I'm gonna add the branch types. So as you can see here, you have 4 options: if, with, else, always. With is if you're using a probability, you would use with this probability, you will go into this branch. Like if 50%, you put with 50% probability, you will go in this branch. In our case, we are using an if statement that is going to be based on a attribute called part type. And we want to send it through this branch if it is equal to 1. So we use a double equal sign to check the value. Part type equal 1. And then if it is not 1, I have the option of doing a part type 2. But since there's only two parts, I'm going to use an else. If you're not part type 1, take the else. So as you can see here, the first one is for part type 1. The second one is for the else. Okay, so now let's go into the drills. For that, we need a queue. Seize. Delay and release. And to save time, since this is empty right now, I can just, because I know I'm going to build another machine, I can select those 4 blocks. and paste another sequence of blocks. So I just select them all, copy, and then paste, and I can connect this to the else. So I need to input the information for the first one. So the queue ID is going to be drill 1Q. You're going to seize drill 1. The delay is going to be based on a triangular distribution. Triangular 3.2, 4.2, 5.2. Got it?
Can you
The
repeat the
Cs.
Cs?
Yeah.
Yes, so the C's, you go to the add block, and you're gonna use the pull down menu to find the drill 1. Yes. And the delay, you put the probability distribution. And in the release, you do drill 1. Got it?
Delay and release again.
Yeah, delay, you put the probability distribution.
Need to type all those things.
You can type it, or you can just build the expression. Go to random distribution, pick the triangular, and then you put minimum value 3.2, most likely 4.2, less, or maximum value 5.2. And I don't think we're gonna be able to finish today. I mean, we might need to complete this. I don't want to rush through this, so we can complete this on Wednesday. So let's do that. Let's stop here, save your model. What we have is just completing the second machine and then set up the statistics. Okay, so make sure that you save this model. We will complete it at the beginning of the next lecture.
What's the distribution for the second machine? Is it gonna be in the PDF presentation?
Yes, it is triangular 3, 4, 5. Yes. Okay. So let's stop here. It's 3:20 already. So and then we'll save it. Make sure that you save it. And then we'll complete the model Wednesday. So I'm gonna stop the recording.
We need to add the response after the release block. Oh, the counter, good catch, my son.
Yeah, there are some statistics that are still missing. You need to put the tallies and the counters. Yes. Say that again.
What one?
Wednesday. Yes. Anybody knows how to go back to Zoom? It looks like it's still recording, but I cannot get access to.
Is it
So,
still running on your machine?
yes.
And where do you see it running?
So workplace. It is recording. Presenting.
Return to meeting.
This one?
Yeah.
Thank you. Stop sharing. And stop.